Hello everyone, thank you very much for joining us today on this webinar called Automotive Verification on Safety Critical Code. I am Sylvia Sanchez, Digital Marketing Executive at QA Systems, and today we will learn about our advanced automated software verification tools, which can help you to optimize your workflow and increase efficiency at the same time as ensuring compliance using coding standards like MISRA, AUTOSAR, CERT, and CWE, and safety standards such as ISO 26262, IEC 61508, and others. This session will show the key benefits of our verification tools using a single code example on how to comply using QMISRA for fast coding standard compliance at the developer's desktop first, test using Cantata for automated dynamic execution of the standard compliance software, and analyze using a string for proving absence of runtime errors on the whole application. Weighing on this topic are Daniel Kaestner, CTO at AbsInt GmbH, and Haydar Akbulut, MBA and Technical Support Engineer at QA Systems GmbH. Please note that you all will be muted throughout the webinar, so if you have any questions, please feel free to type them on the question windows at any time. To open this, you need to use the orange arrow at the top of your right screen or at the top right of your screen, and we will answer them during the Q&A session at the end of the discussion. If you have any technical problems with your audio or video settings, please do not worry. The webinar is being all recorded and we're going to share a link with all of you when it finishes. And without further ado, let's begin with the webinar Automated Verification on Safety Critical Code and go over to Haydar from QA Systems, who's going to give us an overview of QMISRA and Cantata.
Hello, and thank you, Sylvia. So let's start with our webinar. Welcome again to our webinar. In this section, we will be presenting you our tools and continue with demonstrations to show how they actually work in the real environment. QA systems and AbsInt tools provide verification-centric, static, and dynamic solutions to accelerate your software standards compliance activities. Placing these solutions in a linear development flow, starting from specify, defining requirements or designs, and being able to linking these to tests for traceability, through code implementations and build, ending with release, managing the software to ship, and of course certify both developed software and the processes tools used. In the verification center, we start with comply to ensuring the coding guidelines and standards are met, for which we offer QMISRA. For test, dynamic automated execution of software at units and integration levels, we offer Cantata. And finally, when data flow static analysis can be applied to the whole system to prove absence of runtime errors, we offer S3. Using these tools in this sequence is the most effective application of targeted automated verification-centric solutions for accelerating embedded software quality. Let's start with QMISRA. QMISRA accelerates coding standards compliance through automated static analysis at speed, making it viable for inclusion in an efficient continuous integration or DevOps workflow for automated verification of safety-critical software. It is independently certified as suitable for use to achieve the highest seal for all the main functional safety standards. The key benefits of QMISRA. QMISRA supports all coding standards you see in the screen right now and many more. It is very quick, as you will be seeing during demonstration later on. It is precise and avoids wasting time on false negative noise and not understanding alerts. Visualizations and metrics with thresholds provide quality insights and easy to understand reports to support your testing procedures. Unlike other tools, it does not license with the named user subscription only, and reports are accessible offline. And finally, it is fully integrated with Cantata via Eclipse and other complementary tools. Let's look at the software itself right now. In here, you see the QMISRA interface, and I will be using a demo project right now. In here, you are seeing my C files in my project, which I will be doing my analysis. Here, I can, in a static analysis, if I want to do, I can use patterns that I want to ignore, or I can define the options that I want to use, and of course the rules, most importantly, the rules that I want to analyze my software according to, which I can configure in here. For now, I will be using diagnostics for general testing purposes, and of course MISRA C 2012 and its amended one as an addition for my analysis. In here, you can start your analysis with a quick click, and in couple of seconds, MISRA gives me analysis report, as you can see, in 2 seconds, and it found 365 rule violations. Let's look at the results now. The power of an analysis tools comes from not just the analyzing itself, but also how it is giving the results of analysis. In here, you see different categories which you can check your results. Here, for example, I can check the results alerts based on categories, based on files or classification, or most importantly, the rule violations. If I go deep down and select one of the rule violations in here, as you can see, the rule itself is the value of an object with automatic storage duration shall not be read before it has been set. If I double click this one, MISRA will bring me the related alarms in my project. Therefore, if I click here, it will jump to the location that my alarm came. In the screen, you see two sections. Here, this is the original code that I analyzed, that I cannot intervene. In the left side, on the other hand, the analysis file that I can intervene. Here, I can type in a fix that I want to apply after my analysis. And again, check if the change that I made was succeeding the overcoming the alarm. Of course, another important feature is the tool needs to help you in order to solve the issue. In here, when I click the alarm, you see the issue, the related section, and what was it related, the check and the rule itself. If you want to learn more, you can right click and click show help, and MISRA will bring you the help section, and in here you can see an explanation what is happening, what was the check. And then if you want, you can also go directly to the rule itself by clicking this one, and the related rule with included notes will be present to you for your further experimentation. Of course, in a testing tool, it is also important to understand the connections of functions with each other. For example, in here I see one function, and if I right click and click the call display graph, I can see this function has a connection with main and proc 0. And if I click this, I can see the alarms on this function and errors. If you go like this, you can move in all functions that connect to each other. Therefore, MISRA helps you to understand also the collaboration between functions to help your analysis succeed. Of course, lastly, an important factor for an analysis tool is its capability for reporting. In here, I can configure a report based on my needs, or I can use the general report generation. In here, I can use the SG, the HTML, CSV, or XML formats. For demo purposes, I will use HTML. I will select all of them, and in one click, MISRA prepared the formats of my reports, and if I click the generate, it is generated. And if you double click, MISRA will bring you the whole reports for your project, including all the related checks and the results of them. So this was it for the MISRA. Let's continue with Cantata. Cantata accelerates dynamic testing through automation to achieve software safety standards compliance at the possible lowest cost. Cantata is also independently certified as suitable for use to achieve the highest seal for all the main functional safety standards. The key benefits of Cantata are: from framework to test cases, Cantata is capable of automating this stage, so it provides a faster testing experience. Function call controlling features of Cantata empowers the testers for unit and especially integration tests, which we will be seeing during demonstration how powerful they are. No matter what drives the code, coverage up to MCDC with the general coverage results or drill down diagnostics to pinpoint gas pin tests. And of course, tests must be traced to the requirements they verify. Therefore, Cantata allows you to import your requirements, assign them to specific test cases or frameworks, and traces them if you succeed testing your requirements or not. Of course, changes happen and will happen. Whether requirements or code, they will affect your test and test results. Automated impact analysis and guided refactoring features of Cantata automates a lot of test maintenance effort. And finally, Cantata is a specialist test tool and has to work in all full safety critical tool chain. So it's fully integrated with built environments, requirements, and other complementary tools. Let's look at the test execution mentality of Cantata. Cantata unit or integration tests are built and run as an executable. The software under test, any external objects, and other library code is built with the Cantata test script and the chosen tool options. If the code coverage or testability information is used, a copy of the source code is taken at compile time, and the test executable for the target platform is built and run. This is done within supported build IDEs, of which there are examples and/or under the control of Cantata makefiles. This produces various results on the development host in different formats for analysis, which are definitive for meeting any certification evidence requirements. So let's look at all these key benefits in Cantata itself. Here you are seeing the same project that we did the MISRA analysis. It is essentially having the same C files except one additional one, which I will be explaining later on. In here you see my requirements for my project in which I prepared for this demonstration, and it has 4 requirements right now. Let's look at the state machine. As you can see, it is a pretty simple one. It has one while and switch case structure, pretty easy to understand. In Cantata, if you right click and generate test script, you can generate your test script. I will say Cantata do auto test for me to analyze the code and understand what is going on and how I should test this. For this, I will say demo underscore do not confuse with others, and I will select ASIL D, highest level in automotive, as you know, and let's say finish. Now Cantata prepared the test script for me, and it added 2 test cases in it. If I refresh my server, as you can see that my trace catch this test script. As I know, in the requirements one, all states should be reached and proper test cases shall be executed for each function. That means my test script's success is related with these requirements. Therefore, I am just pointing and drop and drag and assigning this here easily. For the other requirements, I am assigning test cases themselves because these are just specific requirements for specific test cases. And now let's run our tests. As you can see, there are some passes, but the end result is a fail. If I refresh here, you see that these 2 requirements are fulfilled, but this requirement is not fulfilled. Let's look at the reason now. If I click the suit part and state machine, the file that I am analyzing, you will see the coverage report. And if I mouse over, you see statements 94% covered and decisions 81% covered. In here, you see different colors. As I also mentioned in MISRA, a good static analysis or dynamic analysis tool needs to help you during your understanding of the results. Therefore, Cantata tells me the green ones that are Cantata covered, yellow ones are Cantata saying partially covered. As you can see, one of the 2 outcomes executed. And here, Cantata says it is not covered because Cantata says by design it is not reachable. Of course, this is a design defect that we used in purpose. At this point, what can a tester can do? He or she can report as a feedback to development that this needs to be updated. Or as I know what to do and how to do my test, I can use the control flow features of Cantata to fix this problem. Therefore, I am adding another test script. This time, I am using a manual one, but again for ASLD, and I am giving again demo name. Right now, you see my other test script, but it doesn't have any test cases for which I will be adding a test case. And here you see the call control. In here, I am saying Cantata to use rand equals 0 for this specific test script. And as I know that because of the design flow that we created, Cantata will never be reaching this case at all. I am telling Cantata that when this comes to here, insert a custom code and use the following one, which is round equals 1. And I'm telling Cantata only do this one just for the manual test script, not the automated one. And then I am refreshing. Right now I have two test scripts, but this one is also to fulfill this one. So I'm assigning this test script to the same requirements like this. Let's run the test script and see the results. Here, my test again finished, but I'm still not getting 100%. But if you notice, the statement coverage is now 100%. Let's look what's happening. Whole parts of the code are covered, but it says while is not covered fully and says it's failed. The reason is Cantata knows that I wanted to test it for ASLD. And in functional safety, as you go higher, the rule checks gets harder. And in here, Cantata knows that for ASLD, all statements should have a counter statement. But in this one, I am just using a simple code. It is while one, and Cantata knows that I didn't put any counter statement for this. Of course, this is another design flow that we created for demo purposes. So let's fix this one. I am then removing the assignments from my requirements. I am using the fixed code that I prepared, basically same one, just as you notice now it is a variable here. And I will be generating a test script, again autotest and ASLD. And for this, I will again put a demo, a test. Now I have a new test script. And for this one, as you remember, I mentioned that I put a variable instead of one. I am using another feature of call control feature of Cantata, which is I can also control automated generated tests. And I say Cantata that for this specific case, I want you to do entry and use entry as 1. And then for this specific test case, I want you to use round equals 0. I am refreshing my server. Now you see my second test script in here. So success of test script is placed on the first requirement. And then, of course, as it is code coverage rule set, I am assigning this one to the requirements to 2. And then, as I did before, these ones for the other requirements. Now let's run our test script. And as you can see, right now, Cantata says that it's okay, you reached all the parts of the code. And if I refresh my server, you see my requirement trace says all the requirements are fulfilled. Of course, as a powerful dynamic testing tool, Cantata also capable of running in continuous integration and DevOps procedures. Therefore, for example, if I go here and test folder and use my command prompt, with just simple commands like this, I can execute all of my tests in command line 2. As you can see, it is running the demo ATest test machine 2, and it is also updating the results in the requirement trees. Thank you for listening. This was all for MISRA and Cantata. Now we will be continuing with AbsInt.
Thank you very much, Haydar. Now we're going to go over to Daniel from AbsInt, who's going to give us an overview of AS3.
Excellent. All right, then let's proceed. So the topic of the last section of this webinar will be AS3. So it's the deep static analysis to find critical code defects and prove their absence. So before going into that, let me briefly sketch the background, why we're here at all. So in general, if you look at any safety standard which is around, of course, it requires demonstrating the functional safety also of the software. And the first requirement you find in all these norms is that, of course, you have to show that the software then is functionally correct. So you have to look at the functional requirements and show that they are indeed met. And the standard technique to do this is testing, hopefully automatic testing, just like we saw before. And then all these safety norms also require to satisfy some safety relevant quality requirements, which are not specific to certain functions, but which rather generally hold for all functions in the system. And well, the first topic here is to demonstrate compliance to coding guidelines, like we also saw in the previous presentation from Haydar. But then there are additional topics like robustness requirements. The software should not crash because of runtime errors like division by zero, buffer overflows, and so on. And if you have a multitasking system, then you do not want your task or threads destroy data from other threads. So you don't want to have data races, deadlocks, or other lock-unlock problems. Another topic here is to show the compliance between the code and the software architecture, and to look at the way software components interact with one another. So how can they interact, and did I really see all possible interactions in my integration tests? So all these three topics will be something we'll be addressed in the next minutes. And then there is also some resource usage requirements. For example, if you have a real-time system, then of course you have to show that all your tasks finish in time. And you also do not want to crash with the Stack Overflow. I am not talking about these issues today, but they belong to the same class here, these kind of non-functional quality requirements, as they were typically called. And the common thing for all of them is that they can be very well handled by static analysis. So that's really the playground of static analysis. And if you use the formal technique for static analysis, the so-called abstract interpretation, you can even prove that defects from these classes are actually not in your code. So you can prove the absence of these defects. What's also nice is that, well, these, if you look at divisions by zero, buffer overflows, or data races, of course, they are safety defects, but they are also security relevant. So they're among the most common cybersecurity vulnerabilities. And if you look at the related cybersecurity norms like ISO 21434, then of course you have to demonstrate or also the absence of such vulnerabilities, which means if you have some way to deal with these defects from a safety perspective, well, at the same time, you're covering also cybersecurity goals, and you're covering both workflows as safety and the cybersecurity flow in one step. Now, before going into the demo, let's briefly talk about what static analysis is at all. So in principle, it just means that you're computing some insight about the program without actually executing it. Okay, so if you do manual code review, that's a form of static analysis. But well, the most interesting cases are, of course, tool-based analysis. And then, well, you can do it in a simple way, just by looking at the syntax of the program. And this is enough already to check a lot of coding guidelines. So in particular, coding guidelines, coding rules, which have been explicitly formulated on the syntax to make them easily checkable and easy to follow. And if you look at the MISRA C norm, that's the decidable MISRA C rules. So all of them you can just address by syntax-based methods. But eventually, well, the most interesting things are the semantics, because you want to know, do I have an error here in the program? And unfortunately, that's undecidable. So you cannot always give a precise yes and no answer. So what can happen if you have a simple tool is, well, you can have false positives and false negatives, which means the tool can say, well, you have a problem there, but actually you don't. And the tool is just, it's a false alarm, and the tool was too imprecise to find out that it was okay. And the really bad case is that you get a false negative and the tool doesn't complain at all, but you really have a defect which the tool missed. So that's really the bad case. And it's not possible to have a tool which never gives false positives and never gives false negatives. But what is possible with this formal technique of static analysis, the abstract interpretation, that you can be sure that you will never run into false negatives. So you will never miss any true defect. False positives are still possible, but you can be sure that you will never miss something critical. All right, so AS3 is such an abstract interpretation-based sound analyzer. And well, what we are doing is to look at the source code, so at the C or C++ code, and to report defects due to undefined, implementation-defined or unspecified behaviors of the programming language. And some of those really can cause severe program defects, like array index out of bounds, division by 0, all kinds of invalid pointer dereferences like null pointers, invalid pointers, dangling pointers, uninitialized variables, and then the concurrency defects like data races, log unlock problems, deadlocks. So that's really the core purpose of AS3. And well, in order to do this, you have to have a complete data and control flow analysis. So you have to know which function can call which other functions, possibly via function pointers. And then you can also lift this to talk about the interactions between software components or the interference between software components. And you can talk about aliasing between different pointer values. AS3 also has a module for taint analysis. So you could, for example, track the flow of some corrupted or tampered sensor values through the program and check whether you always have appropriate checks like authentication checks or plausibility checks. And it can also catch some other interesting aspects about the program. What's also important is that if you have, let's say, an AUTOSAR or OSEC system in automotive or RANK in the aerospace domain, that you can automatically run an integration analysis on the entire software stack, in case of AUTOSAR, taking into account the RxML configuration of the system. So you just need the source code, the RxML configuration, then AS3 will know what happens and compute all possible interactions between the tasks, interrupt service routines, and so on. Well then, what's also very important is that, well, AS3 also includes code guideline checker, and the code guideline checking module of AS3 is actually the same which is used in QA MISRA, and I'm going to talk a bit later why this really makes sense. So, and without further ado, I would change into the demo. So I'm just opening the same project Haydar just used in his example. And I'm going to read the project configuration from an XML file, the so-called DAX configuration, which describes the software project I want to run. So this is a textual XML format. You could also automatically generate. You could put into version control, and which simplifies using these kinds of analysis in an automated continuous integration, continuous verification setup. So I'm now opening the analysis and can just run it. You can see that it already looks quite similar to QA MISRA. We have the section with the top level results here. And well, in the middle part, it looks a bit different. And if we look at the result overviews, we can see that now we have some more categories of alarms. So it's not just the coding guideline checks which have been failed, which are reported, but also things like invalid usage of pointers and arrays, uninitialized variables, division or modulo by 0. Okay, so let's just pick out one of them. So we jump here. we open the list of defects from this class. Then this table opens, which shows all issues of this class, just clicking on the first of them. Then we see the precise information about this alarm in the middle part, the pre-processed code on the left-hand side, and the original source code, possibly with macros and so on the right-hand side. So on the left-hand side, you would see what the macro expands to, so you can easily understand what the issue is. And on the right-hand side, you will still find your macros, so you understand your code as it was written. Okay, and in this case, we see, well, it's an array index out of bounds access. Yes, in this place, apparently we can access with index 10 here. Also, the tooltips confirm this, but the array block actually has only 10 elements. So yes, that's not good. The indices, the feasible indices range from 0 to 9. So obviously we have a problem here. And this is the typical C problem. We start at 0 and then should just run till smaller than 10. Well, let's just quickly fix it here. In the pre-processed code, I can rerun the analysis. And then we can already see, okay, this issue now has gone. Now let's look at the next entry here in the code. So I can click on these triangles and then see everything which has been reported for this line. Well, and in this case, we have a buffer overflow. So we say, okay, we dereference a pointer which points to array block, and it can access beyond the object boundaries. So let's again look at the tooltips. Yes, indeed, it points to array block. Yes, that's the place where a pointer was assigned. And then we have a loop where we do pointer arithmetics and eventually increment beyond the boundaries of the array. So actually, it's more or less the same thing as in this case. We go to index 10 and should stop before. So this is also something you see in the middle part of the message. So I can click here, and then, like if you set the breakpoint in a debugger, you can walk up the call stack to find out how you ran into this particular problem. So here we see, yes, I have my buffer overflow, and it happens in the 11th iteration of the enclosing loop here. And well, I run into this if I call the function basic example at this place, and well, eventually from the entry point of the analysis, which is my main function. Okay, so right here, I just checked how I could fix this. And now let's say I want just to tell my colleagues, well, this is a true defect and they please should fix them. Then I can do such classification of alarms, also possibly leave a comment. I could also use a tag for identifying the alarm. And then you can see that this is shown as an overlay in the code without me having to change the code. So, and okay, then I could also restart the analysis, let it run again, and then the comment would be shown also as a part of the normal analysis log output. Well, in general, when looking at these editor windows, we can see that, well, there's a bit more colors than just with the rule checking. Rule violations are highlighted in blue, and then the yellowish red colors, the darker the color gets, the more critical is the finding. So in that case, we have a definite buffer overflow, so we can be sure that whenever we run here, eventually we'll run into this buffer overflow. So this here is dark red. And if we go to the very end, we can see something which is a lot less critical. So here we would see an alarm about an infinite loop. So Astrid says, okay, this is definitely an infinite loop. Could be intended, for example, if you have an infinite loop in a task body. But well, so we categorize it not as an error, but as a control flow anomaly. And in this case, we can see, well, it's justified. Here we set I to 1. We increment it by 1 in the loop decremented, so it will actually never change away from 1. So this loop will run forever. And this is also something Astrid reports. All right, then let's have a look at one different issue. So for example, this division by 0 here, this is where we can also see the call stack a bit better. So here we have our simple syntactic division by 0. We can see, well, we reach this if we call the procedure 7 from here. It's contained in a loop. Already in the first iteration of the loop, it happens. It's enclosed in another loop. And again, in the first iteration of this loop, we run into our problem. Well, and so you see how we ran into this. And well, of course, also this is justified. So I can comment it again. It's a true defect, and fix it, please. Right. What I can also do is to show the corresponding problem also in the call stack. So I can say, okay, I now want to see how I ran into this issue. And then we can see, okay, I have my divisions inside of procedure 7, and there are actually 3 paths how I can run into this. So going from main to dry main to procedure 0, and then directly to 7, or first 1, then 7, or from 1 to 3, and then to 7. So there are 3 possible paths, and that's exactly also the 3 messages I see here in the context area of the screen. Okay, so we have seen the listing of the findings per category. Haydar has already shown the findings per file view. There is also a view findings per classification. So you can see, okay, in my review process, I have already commented 2 alarms, categorized them as true findings. And well, there is 125 more to go. So you can basically see where you are in your review process. This is this is the overview of the rule violations. So again, we have violations of coding guidelines. Now there is also a view about unreachable code. So Astray can report code which is definitely unreachable. And here you see basically the drill down, how many files have really 100% reached code, and which files have less reached code. You can also sort these columns and then quickly see which aspects have not been covered. So for example, here you could see, well, in this interpolation function, there are some extremal values you never ran in. So it's unreachable code. Okay, and going back to the result overview, well, the code metrics, of course, are also available. And then we have our data flow and control flow view. And now we see a difference to the QA MISRA analysis, because in the control and data flow analysis of Astray, we also see precise information about where certain accesses happen, like whether you have a data race, whether it's a shared access, from which process you have come. So in this case, it's just a sequential analysis. But if you would have several tasks, you would see which task is making this access, possibly on which core, and how many accesses there are actually in happening. All right. So then let's, before I go in the second example, let's switch back to the slides. Okay, that was the right one. This is essentially the example with the state machine Haydar has shown, and it has a classical implementation of a state machine. So it has an endless loop, and then depending on a state, you go to, or depending on the state you're in, you go to certain cases of the switch statement, which then also determines what to do next. So it's a bit hard to understand if you just look at the C code. It's much simpler if you look at the automaton structure. So you see, okay, from state 0, you can go to state 1 or state 2. From state 2, you could go back to 0 or into 1. And you can also see at a glance that, well, when you're in state 3, then you must have been in state 1 before. Now, let's look at the code here. So here in case 3, we dereference a pointer P, which is not initialized upon declaration. The initialization really only takes place in state 1. So here we set, in state 1, we set the state, the next state to 3, and initialize pointer to the beginning of the state variable. So yes, from the automaton structure, it's clear whenever we dereference this value here, then it will always be initialized. But well, when just looking at the switch statement, it's not so obvious. And actually, this is something which is very difficult and which shows how precise Astray can analyze such code. So now let's go into this place. This is the code with the state machine, and we can see, well, Astray does not report an invalid pointer access here in this line. It it can, which means in this case that actually you have a proof that this pointer will always be initialized here. And you can see, well, it must definitely point to state. So ASTRE was able to figure this out. Well, but then we see, okay, here we do have another alarm. So let's click on the line again. And then we can see, well, there is a division by 0 here. Okay. And well, what's happening? So here we have an accumulation, and we basically subtract our sensor input, our sensor event, from a given number. Well, yes, and of course, if the sensor has exactly this number, then indeed we have a division by 0. So, and so you can see, okay, the sensor event has been declared as a volatile variable. If you do an interface contract, you could also specify ranges with ASTRE in this syntax here. But well, if you don't, we have to assume that it can take any possible value, and then you can have this division by 0. And of course, this is something which is very hard to observe during testing, because, well, it's completely infeasible to run the program to every single value of every variable and the combination of that. So that's the strength of these analysis, that you definitely find all defects which may be in the code, also if they are very hard to reproduce. All right, so now let's quickly or slowly get back to the slides if I find the right button, which should be around here. Right, so we have seen that how this example looks in ASTRE. And now let's go back to the data and control flow view. So I've shown it in the tool. And just to summarize what we have seen in the data and control flow view, well, you can see which functions call which other functions, and possibly also in which task function calls can take place. So either you see all calls which are triggered by all the tasks, all your threads in your program, or you can just narrow this down to one particular thread and just see the control flow graph, call graph for this thread. In the data flow analysis, we see the list of global, static, or out of frame accessed local variables, and you see information where there is this access, the location, the function, the process which does the access, whether it's read or write, and what the access properties are. Like, is it the thread local access, or is it a shared variable? Is it even subject to a data race? And what's very important is now the soundness aspect. So the soundness means that no data and control flow is missed, and you can only have this in a sound analyzer, because only then you can guarantee that you will definitely have seen all possible function pointer values and will definitely take into account all possible values of data pointers. And that means that now with this information, you can also go ahead and reason about the freedom of interference between C functions or between software components, if you have a specification of software components you can put in ASTRE. Right, now I've announced to talk a bit more about the relation between QMISRA and ASTRE with respect to code guideline checking. Well, so if you have a syntactic rule, the decidable rules in MISRA, for example, then you can be absolutely precise. So there doesn't need to have to be any false negative and no false positives. You can just precisely check this. It gets interesting when we go into the semantics, but still, a lot of the MISRA rules are syntactic. So that's really the focus of QMISRA then, to have a fast and completely automatic analysis, essentially a push-button solution, which will report all the syntactic rule violations precisely, and when dealing with semantical rules, try to keep the noise at an absolute minimum. So yes, we can have false negatives on semantic rules here, well, because it's not a sound analysis, but we try to keep the false positives at a minimum. So if you see a violation of a semantical rule, then, well, the chances are that this is indeed justified. But it's a simplified analysis, which is very quick, very easy. And then you can combine this with ASTRE and then again configure the semantical rules for the ASTRE analysis. And now you will have no false negatives on these semantical rules, because of course there are undecidable MISRA rules like no access beyond the object boundaries. And there is even a rule there should be no runtime errors. It's rule 1.3. So this is exactly what you can cover with ASTRE, and even in a way that you can be sure that no violation of these rules will be missed. Regarding the false alarms, AS3 is very precise, and well, it's actually in let's say the false alarm rate is minimum if you look in the field what analyzers are around. Well, the analysis can be computationally more intensive, so you have seen that it takes longer than just a QA MISRA analysis, and the setup can be more complex, so you have to specify an entry point for the analysis. And if you know that you're operating in a certain context, you can provide, let's say, an interface contract to AS3. What are your input signals? Which ranges can they take? So this is something you can do to make the analysis more precise, but it also means that, well, you can configure more. Okay, so let's look at the different use cases you have with AS3. So, well, the obvious thing is that, of course, just like your MISRA, you can use it to report code metrics and reason about the general, let's say, general quality figures, quality numbers. And then beyond that, well, it's the software developers or the software integrators side, which you see here. So from a developer's perspective, you can, for example, check coding guidelines at the single translation unit level, okay? And also the undecidable rules, for example. And then basically at the software component level, of course, it also makes sense to run this analysis to find defects early. So for each software component from the developer, you can run the abstract interpretation to find runtime errors, unreachable code, look at the data and control flow in your component, possibly do a cybersecurity analysis of your component. And then the integration view, you can do similar, pretty much the same, like the abstract interpretation-based analysis to look at runtime errors, unreachable code, data control flow, cybersecurity issue over all the different components, including now the interaction between the different components, and then can reason about concurrency defects. Do I have data races here? Do I have lock-unlock problems? And so on. Okay, now in a certification, in a safety context, it's very important to be able to say, okay, the tool I'm working with really is fit to do what I wanted to do, and this can be done by qualification support kits we ship along with the tools. And so this is essentially the ISO 26262 requirement we are covering here. So you can see it's highly recommended if you have SLC or D software and your tool is classified TCL 203, well, then what's highly recommended is to validate the tool and to demonstrate development in accordance with the safety standard. And this is exactly what we can demonstrate with the qualification kits. There is a formal report listing all functional requirements to the tool. There is a detailed verification test plan, how to check each requirement. All these test cases are shipped in a validation suite you can automatically run, and which generates a report so that you can demonstrate that, yes, in your installation of the tool, exactly on this machine, how you have installed it, all these functional requirements are actually satisfied. And well, there is also the tool lifecycle data, so we document our tool development and verification process and can demonstrate that we have a reasonable development process. And this is enough to basically automatically qualify the tools for any safety standard around up to the highest criticality levels. Okay, so I have shown how to operate with the graphical user interface. Now what I quickly want to show is also the batch mode execution, because actually anything you can do from the user interface, you can also do from batch mode. So here in this folder, I have the XML configuration of the analysis, and I have a simple batch file. I can just execute. So let's just do it. And then you can see the command line. So I'm invoking the launcher for AS3. It's a client server architecture, so it tells where the server is running. I have the configuration file of the analysis and just tell it, well, I want to have a textual report file, an XML report file, then a condensed XML result file, which just contains some numbers I could use for a dashboard, and then which exports an AIF archive, which contains the entire analysis state. So if you can import this into the user interface, and then it would be just like you just ran the analysis in the user interface by hand. And you can see, well, it ran, and now we also have our reports. So this is a textual report. That's now the result report. So you can see it's an XML file. It just contains some numbers like, well, I have 4 definite runtime errors, 18 runtime errors overall. I have 88% reached code and so on. So that's the high level information. Then there is the XML report file, which contains all the details about the results, all aspects. So you could post-process this and query whatever result you want to have. There is also an HTML report, which is generated, where you can also find all the findings, the analysis configuration, and so on. So all is there. And I can also basically go in the tool and just import this archive I have just created. And then you can see, okay, now it pretty much looks as before, where I just ran the analysis by hand. So basically everything is there. So that means it's very easy to automatically run the tool from the command line. All the functionality is available. And this is pretty much also what we have used for as the basis for the integrations which are already there. Like there is a Jenkins plugin, an Eclipse plugin, an integration into Kai Microvision, and there is a toolbox for target link. So you can also automatically launch the tool from the MATLAB Simulink environment. And for example, also use the model link to jump back into the model. Okay, and this concludes the part about AbsInt. And then I hand back to Sylvia.
Thank you very much, Daniel, for explaining us about AbsInt and how all the 3 tools can be used in a continuous integration pipeline. We're not going to move into the Q&A session, so please use the question box to type any questions that might have been left, if you have any. I will allow you a bit of time. So far, thank you very much to everyone who has submitted some questions. Just please know that if we don't get the time to answer them all today, we're going to send individual emails to reply them after the webinar. So let's welcome our speakers one more time, Haydar and Daniel. There you are. So the first question is, can you add individual rules for the static analysis which are not in a standard? I believe both of you can answer this question.
Yes, so in principle, there is a fixed configuration of rules. So we cover the usual coding guidelines, and some rules you can configure so that, for example, there are rules how identifiers should be structured. So you can provide patterns and then adapt the rules to your need. And then it's also possible to add other rules which are not covered by any safety norm which is around, but typically we do this as an engineering service, because then you can also automatically qualify it. So if you would just have a toolbox to plug in your own rule configuration, then you would not have the advantage of the automatic qualification.
Thank you very much. Second question. During the demo, you were using ISO 26262 ASIL D standard. Is there a separate package that we need to buy? And if so, do we need to buy it for all the standards? This question is addressed to Haydar from QA Systems.
Yeah, actually, no, you don't need any additional package for major function safety certifications like automotive one, railway, nuclear. It all comes with content out of the package. Only one that you might need to add additionally is the DO170, which is for aerospace and defense one.
Okay, thank you very much. Third question here. How do you determine if any third-party library do not have errors? This question was particularly made during Daniel's presentation, so I'm going to let him to answer it.
So there are two ways you can deal with this. So if the third-party library is available as source code, you can just analyze it, and then it's transparent to the analysis. If it's not available in source code, then it's still possible, let's say, to mimic the behavior of this external library by providing some stubs. But then, of course, the behavior of the library has to be independently verified. But if you have it in source code, it can be just analyzed like the rest of the code.
Thank you very much, Daniel. There's another question that just arrived now. Is addressed to Haydar. He is asking if the full MISRA C++ 2008 rule is covered.
Sorry, can you?
Yes, sorry, the question is addressed to you. It just arrived. So someone is asking if the full MISRA C++ 2008 rule set is covered.
Yes, maybe I can jump in. So actually now all the rules we consider checkable are actually checked indeed. And so we basically finished the whole coverage right now, and just right before the next C++ MISRA standard, MISRA C++ 2023 comes out, which is announced for the middle of the year.
Perfect. Good news then. Some people send questions related to the possibility to try. So Daniel and Haydar, is it possible to try out the tools?
Yes, of course.
Yes, of course.
They just need to reach us, and we will be helping them to evaluate licenses. And if they need any help for Esther, Daniel, or for QMISRA and Cantata, myself or our team, we will be happily helping them.
Good. So finally, we receive a question that says both QMISRA and Cantata are from QA systems. Is there any advantage of buying them together? And for someone that uses both tools, can they both work together?
Actually, yes, there are two advantages to getting them together. The first one is the practicality as they are capable of integrating to each other. QMISRA, in fact, can be used inside Cantata without opening QMISRA at all. Therefore, if you get them in a bundle, you can use just one tool and get the benefits of both of them. The other benefit is financially. If you get both of them, there is a special bundle that you can use, and it is way cheaper to buying them separately. Also, it is applied to existing customers too. So existing customers can also buy QMISRA as a bundled addition to their current licenses.
Thank you very much, Haydar. Thank you very much, Daniel, as well, for joining us today. Unfortunately, our time is up, so thank you everyone to join us. And if you would like to find out more about our tools, the organizers will get in touch soon after the webinar. There will also be a short survey on what you thought about this session, so please take your time to fill it out to help us to improve the quality of our content for next time. Thank you very much for watching, and have a nice rest of your day.
Thank you. Bye-bye.
Thank you. Have a good day.